Okay, so in this video we'll be talking about the combustion of metals. Okay, so some things to think about when you see combust, when you see burned, combust again, lit on fire, reacts with oxygen. All of those things mean combustion, and what combustion means, really, we're adding oxygen. Okay, technically we're adding a little bit of heat, or a lot of bit of heat sometimes, but oxygen is the big thing that you've got to remember whenever you see combustion, burned, light on fire, stuff like that. Okay, so in this case, every time we have something burn or combust, we've mixed it with a metal. Okay, and so that's why we call this the combustion of metals. Okay, so really these become fairly simple because you have your metal, magnesium, is added to, well, it's burned, and now that we know combustion really only means that we're adding oxygen to the equation. Every single time we have combust of anything, even a hydrocarbon, we're just adding oxygen each time. Okay? Now, in the combustion of a hydrocarbon like CH4, okay, your products are going to come out to be water and carbon dioxide. All right. In this case, in the combustion of metal, our products are always going to be a metal oxide. So in this case, our metal is magnesium oxide. Okay. Now we still need to check to make sure we use our ionic rules over here. So magnesium is a +2, oxygen is a -2. When those cross up, they cancel each other out. So we're just left with MgO. From here, we should be able to finish it out by balancing 2 oxygens. Now I have 2 oxygens over here, but I've also created 2 magnesiums, so to balance that, and there we have a correctly balanced combustion of magnesium. So the same thing down here. Now that we know that iron is combusted, we're going to add O2, and we should always come out with our metal oxide. Okay. Now in this case, iron is Fe, and there was a little typo there. This should be iron 2 combust, okay? Because, and then copper, let's do copper 3 down here, and then lithium is not a transition metal, so that has a set oxidation number. With these two, you should know that they are transition metals, and so they need a Roman numeral with them. So let's just use iron 2 and iron 3 for each one of these. So that's going to come into effect when we have our product down here. So iron combusts with oxygen to give us a metal oxide. In this case, it's iron oxide. Now, this iron is a +2 because we have iron 2. Oxygen is a -2, so when they cross up, they actually cancel each other out to be 1 each. So it's going to be the same balancing as we did in the top one, 2 to balance out the oxygen, but now we've got 2 irons on that side. Okay, down here for number 3 we have copper 3, so it's just going to be copper. All right, that 3 doesn't come into play until we need to cross up oxidation numbers. Okay, so then that's going to create our metal oxide, copper oxide. So once again, oxygen is -2. Copper in this case is going to be a +3 because we're using copper 3. And now when we do cross those up, it comes out to be, to write a little bit more neatly over here, copper plus O2 will give us copper 2 oxygen with a 3. Okay, and from here you should be able to balance the correct way, and then I'm going to let you do this one on your own. I hope that helps.